Okay, so today we're going to be talking about powers of I. When I say powers of I, we mean the square root of -1 is equal to I. So we're going to be talking about these powers of I here. Okay. Now the reason, what the different powers that we'll be talking about are things like I squared is equal to what, I to the 4th is equal to what, and even I to the 224th is equal to what. Right? Okay, so let's go ahead and get started on these problems. Let's go ahead and get started. Okay, so the first thing that I want to start with is just giving some common rules here. Now, if the square root of -1 is equal to I, now watch this. Let's say we have the square root of 4. That's equal to 2, of course, right? So let's see if we take this number and we square it. Let's say we take this number and we square it, right? We take this number here and we square it. So let's square I, right? What do we seem to be getting here? If we take 2 squared and we get 4. So if we take, and that's the same number that's here, right? So same thing, if we take I squared, we should get the same number that's here, which will be equal to a -1. Okay? So there, we came up with a rule, and that rule, it says that rule here, it says that I squared is equal to -1. Okay? Alrighty, so let's go ahead. So we can erase this here. Okay, so let's go ahead and say I squared is equal to -1. Okay. Now we're going to use these rules to solve the rest of our problems. Let's go ahead and get started. If we have, let's say we have a basic exponent problem, right? We have a to the n power times a to the m power, right? We know that when we multiply these, we actually are doing what? We're adding. This will be a to the n plus m, right? Same thing with real numbers. If we have 4, well, let's say x to the 4th power times x to the 6th power, we're looking at x to the 4 plus 6, which will be x to the 10th power, correct? Okay, so we're going to use, like I said, we're going to use this information here that we've gathered from here to actually get our complex number, to solve for I, to solve powers of I, okay? So, let's say we have I raised to the 4th power. Okay, based on these rules over here, we're allowed to break this up, right? Because look at this here. If we have, let me write in a different color here. If we have, let's say, give me a second. If we have I, let's say we have, instead of I, let's say we have m to the 10th power, right? Let's write that a little bit more clear. M to the 10th power, right? We can say this will be m to the 5th times m to the 5th, right? Because the rule, based on the rule up here, when we multiply powers, we're actually adding them, which will be m to the 10th. Okay, same thing here. I to the 4th will be I squared times I squared, right? Because 2 plus 2 will equal 4, right? What did we just say I squared was? We said that's -1. So -1 multiplied times -1, which will be +1, right? So we say that I to the 4th power is equal to +1, which is what we have right here. Okay, great. Let's go ahead and do some more. Since you understand this, let's go ahead and do some more here. Let's say that we have something a little bit bigger. I to the 7th here. Let's say we have I to the 7th. Okay, so I to the 7th power, what we're actually looking at here, let's break this down into stuff that we know. Okay, I'm going to tell you another general rule here just before we continue. Okay, go ahead and copy this down here. Any I, hold on, let's say this here. Any power that is a multiple of 4, any power that is a multiple of 4 with base I, assuming that I is equal to the square root of -1, is equal to 1. Okay? It says any power that is a multiple of 4 with a base I. So this basically means anything that has, so any I raised to any multiple of 4. So if we can do 48, we can do I to the 16th, we can do I to the 24th, we can do I to the, let's just get it, I to the 36th. All of these are multiples of 4, so these would all equal 1. Right, I to the 16th is equal to 1. I to the 24th is equal to 1. I to the 36th is equal to 1. Perfect. So we can use that information given there to actually simplify our exponents here. Right? To simplify our exponents on the I. Okay. So let's see here. So if we take I to the 7th, we can break this down into I to the 4th times I cubed. Now we already know what I to the 4th is because that's a multiple of 4, of course. So we'd be looking at a 1, right, times I cubed. Well, we hadn't talked about what I cubed is equal to, but let's do it. It'll be I squared times I to the 1st, right? Because this will be I squared to the 1st, I squared times I to the 1st, which would be, we add the powers, which would be I cubed, which is our rule over here with this in the blue and maroon. Okay, so if we have I squared, so let's go back to where we're here, right, is equal to 1 times I squared, we said is negative 1, times I to the 1st, anything to the 1st power is itself, right? Okay, let's simplify. Negative 1 times 1 is a negative 1, multiplied times I. Now we know when we're multiplying anything times 1, it's going to give me the same number. But when we multiply it times a negative 1, not only does it give me the same absolute value of that number, but it gives me the different. It changes the sign. So this is a negative I. It's going to change to. I mean, this is a positive I. It's going to change to a negative I. Okay. So basically, what this is saying is that I to the 7th is equal to negative I, and we did it based on our rule here. We did it based on this rule and this rule, breaking down the powers and also knowing that any power raised to, any I raised to the base that is a multiple of 4 is equal to 1. Okay, so let's go ahead and get, like I said, let's go ahead and get some more problems here. Well, let's go ahead and stop this video and then we'll resume the video we'll resume the next problems in the next video.